Hi everyone, I am Punit Rajesh. I am studying software architecture and design. In this case study, I discuss about a layer design with different styles for the layers. Let's be discuss about interactions of design with different layers. The layer design with different layers for the layers is a strategic approach used in the various fields such as the graphic design, architecture, software engineering, and even organizations such as. And this matters involves breaking down complex systems or structures into the distinct layers or levels, each serving a specific purpose or functions. What sets these approach apart was is the deliberate of uses of the different styles, techniques, and methodologies for each layer, tailor into automate its performance or achieve their specific objectives. The purpose. The previous system Fisher controls offers the distributed process control for a chemical protection process, like a process control capabilities ranged from simple control loops that control pressure, fold, and levels to complex strategies and involving interrelated control loops. Provisions are made up for the integration with plant management and information systems. In support of computer integrated manufacturing, the system architecture integrates the process control with management and information systems in a five-level hierarchy. It shows this hierarchy. The right side is the software view and left side is hardware view. Purpose. Each level corresponds to a different purpose management function which is their own decision support requirements. Level 1 process measurement and control direct adjustments of final control elements. Level 2 process supervision and operations console for the monitoring and controlling. Level 1. Level 3 the process management computer based plant automations including management reports, automation strategies, and the guidance to the operation console. Level 4 and 5 brands and cooperative management, high level of functions such as the accounting, inventory control, order processing, scheduling. Different kinds of the computations and responsible times are required at different levels of the hierarchy. Accordingly, different computation models are used. Level 1 to 3 object oriented, levels 4 and 5 they largely based on the conversation data processing especially models for processing purpose. It suffices to examine the object-oriented model of level 2 and responses of level 4 and 5. For the control and monitoring functions of level 2 and provides uses of the points and locus of access process control. It shows the canonical form of a point definition. 7 specialized forms the most important kinds of control. Let's discuss about the function of features. User interface UI. These layers focus on the presenting information and interacting with users. User experience. Applications of UX. The features are aimed to enhance the overall user experience, including ease of use, responsiveness, accessibility, styling, and theming. It includes the features related to the visual design, such as layout, colors, typography, and branding. Business logic. The features in this layer implement the core functionality of the applications, including algorithms, calculations, and rules. Workflow management. This involves the features for the managing overall of data and process within the applications, often through state management or workflow automation. Functions of features, error handling, logging. These features deal with the error detection, reporting, logging to the facilitate double sorting and debugging. Data models. The features in this layer defined such as and the behavior of the applications, data entities, including validity rules and realizations, business rules. This includes the features related to enforcing business logic and constraints on data manipulations and transaction domains services. These are the unreusable components that encapsulate domain specific and operational behaviors. The problem. The complexity management. Managing the complexity inherent in a layer design can be challenging, especially as a number of layers and the interactions between them grow. Developers must carefully design and document relationships and dependencies between the layers to maintain clarity and facilitate the the maintenance and troubleshooting, the consistent cohesions, ensuring consistent cohesion across the layers with the different styles can be difficult. The development must establish the enforced coding standards and design guidelines and architectural principles to maintain the coherence throughout the systems. Without proper governance and inconsistency in naming conventions, coding styles, or design patterns can lead to the confusion and inefficiency. Performance overhead, introducing the multiple layers and abstractions levels can impose the and performance to overhead, particularly and the systems and with engagement performance requirement. Development must carefully balance with the benefits of abstractions and separations of constants with the potential performance impact, employing techniques such as the caching, lazy loading optimizations to mitigate overhead where possible. We discuss about the problems. The problems and solutions. Model discussions break down the systems into the smaller, manageable modules or components within the each layer. This promotes modularity, reduces the complexity, and facilities easier the maintenance and evolutions of system. The clear interfaces construct the defined clear interface and constant between the layers and minimize to coupling, ensuring interoperability. This allows the easier regression testing and versioning of the individual levels. Constant distant design patterns establish consistent design patterns and coding standards across the layers to promote the cohesion and maintainability. Command preparations and standards to ensure that all developers adhere to them constantly. Automated testing implement the comprehensive automated testing strategies including unit test and end-to-end test to verify functionality compatibility of each layer. Continuous integration completes the pipeline can automate the purpose and ensure that changes to the not introduced to regressions. Let's discuss about the results. Scalability modeler such as of the layer design allows for the easy scalability. Each layer can be scaled independently based on the demand, enabling the system to handle increased workload or user base without the significance and architecture changes maintainability by into the distinct layers with the well-defined boundaries. Developers can easily update the individually components without the impacting other parts of the systems. This promotes the maintainability and utilization ongoing in the development and enhancement. Flexibility. Different styles applied to the each layer provide flexibility to choosing most appropriate technologies, frameworks, and design patterns to meet specific requirements. This allows for the customization and optimizations of each layer and based on the unique functionality and constraints. Use reusability components within the layer designed to be usable across the different parts of the systems and or even in future projects. This promotes co-reuse duplications and development efforts. Conclusion: the layer design with different layers for the layers a powerful framework for building up a system across the various domains, from software engineering to the architecture behind. Through these discussions, we have explore the benefits, challenges, solutions, and results associated with these the approach by breaking down the system into the distinct layers. Each it is the set of the functionality sale developers can achieve the usability of the advantages. This include scalability, maintainability, flexibility, reusability, reliability, performance, optimization, security, and adaptability. So we discuss about all of this. Thank you for uh, thank you for listening.